Good morning, students. This is your computer teacher, Charan. I hope you all will be fine. Let us start this 12th topic by using recursion, a new loop. And what about this loop? I'll teach you. Keep patience a little bit. In class 11, I taught you different types of loops. Some loops are ending with a finite value. Some are infinite, never ending. Okay, some loops you can stop, some loop you can break in middle. Also, loops can also be called through functions. Function also I taught you in class 7, right? You remember that some functions are returning value, some are not returning value, some are calculating value in the main program only, some are returning to main program, some are calculating value in the function only. So recursion is a very special function which will call itself in a finite number of times. That finite number is given by you, and this recursion is going to call that function again and again. So you should define a particular task, and that task will be repeated again and again through this recursive function. Okay. So let us start this recursive function one by one. I am going to let you explain what is this. So it is a special function that call itself for more than one time, and once it is being called, it will go till a finite condition is not going to be reached for the function to stop. Okay, it is also defined as calling again and again function. That's why it is written here. Here you check endless loop. That's why it is written here endless loop. Okay, so now you might be wondering that how to write this endless loop, what are the contents in that endless loop, what are the elements of this endless loop. So let me tell you, all elements are same as looping. You also know that in looping, what are the 5 essential elements I taught you in class 11. Just recall that. Just recall. There should be a task, there should be a starting variable, there should be ending variable, there should be a condition, and there should be a incrementation or decrementation step that is going to make the loop. So here also there should be a terminating condition, the condition that should stop this loop. Okay, there should be starting value which will start the loop. There should be a condition which will to be checked again and again, and there should be a calculation, some sort of computation done in this recursive looping. Okay. Also, the condition set by user to stop the loop can vary. Okay, either it depends upon the type of program, the type of work this recursive function is going to do. It can be you can make this recursion either in ascending order or descending order. Ascending means what? It can increase or it can decrease. It can go in increasing order or it can go decreasing order. Already I taught you in class 7. Increasing order means what? That incrementation will go, and in decreasing order what? Decrementation will go. We have to use plus sign and minus sign. That's the basic difference here. Okay. Also, this recursive function is based on I taught you in class 11 about memory management, about stack and queue arrangement. Recalling that? What is the queue? Suppose you are standing in a queue for a movie ticket. So the very first guy is standing is the first one to go out with a movie ticket, and the last one is the last guy to go with a movie ticket. Okay. And what about the stack? In the stack, let me give you an example. Stack of plates on a table. You went to a party. In party of wedding, stack of plates are there. So the very first plate in is the last one to go, and the very last plate in is the first one to go. So this stack is the basic of this endless loop. Let's see it. What is this? It is a recursive function that call itself. Okay, and it is also defined as what? To do some work. Here you just check out this x, and here is this next x. This x is the variable, and this is the calling function. Again, same here, next x. This x is the value, and this x here, next x is the next x value. Are you getting me? Just check out this one. There can be two type of this function definition here, which can be recursive, which can be non-recursive. Non-recursive already I taught you in class 11. This is recursive case here, which means it will call itself again and again. Okay, now let's see this example here. What about this factorial here? Factorial of n, factorial of 2. Let's suppose what you are going to write here, n minus 1, like that will go till 1. What is this 1? 1 is the condition to be met. Factorial of 2, what is that? 2 into 1. Factorial of 3, what is that? 3 into 2 into 1. Like that go on. So this is recursion, where here you see factorial of n is equal to n into n minus 1. This is recursion, where a function is going to call itself again. Okay. Do check it out. This one once again. Factorial of n is equal to n. What is the n? N is the value of that factorial, or n is the value of this calling function. And what is this n minus 1? It is the value of the same calling function, but it is being reduced to 1. Why 1? Because it is recursive function. Alright, come back here. Check it out here. Factorial of 4 can be written as a factorial of 4 into 3 factorial. Factorial of 3 can be written as a 3 into 2 factorial. Factorial of 2 can be written as a 2 into 1 factorial. 1 factorial is 1 into 0. 0 is the stopping condition. Okay, just check out. If it is 0, then it will become 2, 1, then again compute 6, and then again it become 24. This is recursion. You are going to make a program more smaller, more compact, more precise. So less number of coding, but it will work. Here you check it out. Our definition here, same like in class 11, we are defining function, defined, then recursive function name, then value, what you are going to pass, returning, non-returning, up to your choice, is it? So we are going to make this one out. I am going to show one example to you, but before that, let's see this one. Suppose here we have to find factorial of 4. Then what to do? Factorial of 4 into factorial of 3. Just check out here. Then again, Python is going to do. This is Python. Python is going to do. What is that? 3 into 2. Factorial of 2. What is going to do? Factorial of 2 into factorial of 1. Factorial of 1. What is going to do? Factorial of 0. This is the stopping condition here. Then factorial of 0 is what? 1. Then check it out. This is the answer. 6, and then again here it will go to 24 stack. So just check out here that what is the difference between the recursive function and interactive loopings, what you've learned in class 11. Interactive looping means what? It can go either in any order, ascending, descending. You can stop. It can execute according to steps. One step is clear, then you can go to the next step. But in recursive, anyhow, it is going to call the function again and again. Okay, let's check it out. This one, finding factorial. So let me take one example to you, then it will be more clear here. Let me write this. I am going to write here. Let's suppose I am going to write here define. Then I am going to write here define. Let's suppose I am going to print my name 5 times. Okay, so I am going to write here name. Then I will put some value. Let's see what value. So I am going back in the main program here. I am writing x equal to 5, and I am going to call this function name, and I am going to call this function name how many times? X times. This is my main program. Then I am going back here. Then I am coming back here in definition. What I have to do? I have to check it out. First, I have to pass here the parameter that x will go here. Okay. Then I am coming here that if what the x is equal to what is that? 0. Then what to do? Return. Do nothing. Simply come back to the main program. Your main program is here. This is your main program. Okay. Now here, if it is not, then what to do? I am going to write here else part. Then I am going to write here print. Let's suppose your favorite name. What is that? ABC. Okay. Then again I am going to write here what to do? Return. Then what to return here? Return that name. It will call itself. And since we are starting from 5 and going to 0, then this should be a type of decreasing order. Okay. So it is going to call itself. This is your main program. Make it up. So this name is going to call itself again. Let's check it out whether it is running or not. I am going to type. Just check it out. ABC. 5 times it is running. Okay. No problem. Okay. This 5 is here. Suppose I will go through 1 here. Okay, 1 to 5. Then definitely if x equal to what is that? Not 5, 6, because 5 time I have to write here. So this is 6. If x is 6, then what I'm going to do? Here I have to increase it out. That's simple logic, programming logic. I taught you in class 7. Remember that. I am running it out here, see 5 times. Done. You understood? 5 is running automatically. So now let's check it out. I put this for demo here to input a number and print it factorial. And printing factorial already I taught you in ascending or descending. That is up to your choice. According to question given, you can do it out. Okay. So I'm going to type it out here. X equal to. I'm going to write here integer. Then I'm going to write here what is that? Input. Then I'm going to write here enter a value. Okay, let's suppose you are going to enter a value. Then what is that? I am going to here write print. Let's change this name to factorial. Then I am going to put this factorial x here. Okay, print this. Then here this name should be changed to factorial, and here again I am going to check it out. I have to go from a number to 1. So if x equal to what is that? 1, then return. What it is going to return here? Return x. Else what it is going to do? It is going to do nothing here, but it is going to return x into then here fact, and here it is descending order, so it will be -1. Just check it out. Let's see. Enter a value. Let's suppose I put enter a value 5. 120 is coming. Okay, again I'm going back here. Suppose I want to make it in ascending order. Then what to do? Then I have to pass a parameter. That parameter will go from 1 to that number. Are you getting me? What I'm going to use? So instead of this x here, it will go to a parameter. Suppose I'm going to take here y. Let's suppose y equal to 1. I had given here. Ascending order I'm teaching you out. Now I'm going to pass a parameter here y. So this x is 5 and y is what? 1. This x is 5 and here y is 1. So this y is going to be, so here what is that? Here I'm going to write here y. Y is equal to what is the value here? X means 5. Got it? Then it is going to return and again here you are going to make it out here x into factorial. Again it will go here. I am going to write here, if we are not changing this x comma, this will be what is that? Y plus 1. Okay. So what is the factorial here? X into again this factorial will be what is that? I am going to make it here y into, and this will be returning what is that? Y. Okay. I am going to check it out. For this case I am going here running enter a value. So that value will go here. I am writing here 5, then 120. Got it? So both I had explained to you, returning in ascending order or returning in descending order. Got it? I hope so. This all must be clear to you. This is a recursive function. Okay. Now come back here. I do have something for you. So today's discussion for our topic is mainly based on recursive function. We have seen recursive function. I had given a demo for recursive function also that go in ascending or descending order. So this is your hand-on experiment. This program you have to do today. Okay, write a recursive function fact which will take an integer argument from the main program and will return its factorial value to the main program. Okay, you are going to do this program in your computer, in your mobile, and you have to write the full program. And I'll give you this as a lab to be written in a lab copy, but till now you simply write the program and keep it in a copy. Okay, till that time, this is end of our discussion for today's class. Okay, so we are going to meet tomorrow, and tomorrow I am going to teach you recursive in list. Okay, so be ready for the list. Okay. Okay, so goodbye. Okay, be safe. Be safe. Okay, guys.